Hi, I'm Alex Reeve, better known as IB Crazy, and in this video series, I'm going to convert this old hunk of junk into a radio-controlled FPV lawn cutting machine. We're down here in my garage, and normally there are two motorcycles sitting here, but instead, I have this old commercial lawnmower that I found on Facebook Marketplace for $600. While it's a nice commercial grade machine, there's one problem with it. It's got a blown motor. Therefore, I'm going to need some tools to figure out what's wrong with it. So, let's get started. So the problem with this engine is that it's completely seized up. That is, it won't move no matter what you do. You can see that the flywheel's exposed on top of the motor, and that's because the owner before me had pulled the cord so hard that he actually broke the pull starter. The valves appear to be free and so do the lifters, so I'll have to dig a little bit deeper into this engine to see what else is going on. First, I'm going to have to remove the valve lifters. I'm also going to have to remove the intake if I'm going to want to get this head off. Now I'm getting ahead of myself. For some reason, every time I rebuild a motor, I forget to remove the exhaust first. So here I am loosening up the head bolts. Note, I'm going in an X pattern to keep it from warping, but it's not going to go anywhere with that exhaust still attached. Here I've already taken the airbox and the carburetor off to give me easier access to the exhaust pipe. Luckily, it came off easy. And of course, being a motorcycle mechanic, I'm not used to having a governor on an engine. Usually this would pop off, so of course I forgot to remove the governor. Removing one last bolt, the head of the engine comes off. I need this section up because it's nothing more than me removing the head of the engine on the other side since this is a flat V-twin. Of course, first thing I'm going to have to do is remove the valve lifters and then pull the rods out. Once those are out, I can remove my head bolts, again loosening in an X pattern to keep from warping the head, and then I'll go ahead and remove the head once that's loose. Here I'm shooting Seafoam Deep Creep penetrating oil into the engine. I saw a YouTube video that reviewed all kinds of penetrating oils and this seemed to be the best, so that's what I'm using to try to free up this engine. To try and free it up, I'm going to use a block of wood and a rubber mallet. I don't want to use metal tools or anything hard as I could crack the piston. All I'm trying to do here is work it free. Admittedly, I expected the engine to turn by the time I hit the other piston, but it's not moving. Okay, on to plan B. I'm just going to crank the snot out of this with a big heavy ratchet. And luckily, guess what? It actually moves. Now I wouldn't say it moves freely, but I've got the engine actually turning, which is a lot better than what I had earlier. So I would consider this a success. Unfortunately, the amount of resistance I was feeling let me know that the engine in fact had to come all the way apart. And to do so, I removed the engine from the frame, as you can see here, and I'm removing the bolts from the bottom of the engine to take the oil pan out. This is different for every mower, so I left the part where I removed it out. I then hit it with a rubber mallet. Again, we don't want metal on metal contact, just rubber. And then, using a screwdriver along some of the edges, I pried it up. Here I'm inspecting the rest of the engine to see if I can figure out if anything else is damaged. The camshaft seems to be in decent shape, so that can be reused. The oil pump also seems like it's working, so that can be reused as well. The crankshaft, on the other hand, doesn't look so hot. Unlike an air-cooled motorcycle engine that I'm used to, the pistons in this engine have to come out of the top of the cylinders, rather than the cylinders being removed from the block. So I'll have to remove the bearings down below here. Upon inspection of those bearings, yeah, they're toast. They're absolutely destroyed. You can see the grooves cut, especially in the one bearing. That means the crankshaft is probably going to be no good. So here I'm rotating the engine to get the piston as high as I can on the cylinder so to make it easier to remove. Since the connecting rod and bearings are destroyed anyway, I don't have a problem using metal tools to drive it out of the top of the cylinder. Came out relatively easily, and looking at the piston, we could see heat and scoring. Piston could probably be reused with a little bit of machining. The rings are stuck, but I think it can be reworked. To clean up the cylinder walls, I'm using a glaze breaker on a drill. You can find these at most auto parts stores, and all they are is basically a stone sharpener run around the inside of the cylinders. I'm removing the little bits of piston that got stuck on the cylinder walls and overheated, which caused the engine to seize. Apparently I forgot to hit the record button on how I got the crankshaft out. There's a big nut on top of the flywheel. I just locked the flywheel up and broke the nut free and then pounded the crankshaft out with a hammer. It popped out relatively easily with nothing in the way. Now the only thing I have to do is clean out all the metal shavings that I have, make sure the cylinders are nice and smooth, and we're ready for reassembly, I think. Here you can see the damage to the crankshaft. The bearings have actually melted to the crank itself, so luckily I found one on eBay for 60 bucks that I'll be installing. When rebuilding an engine, you'll need a good assembly lube. I like this Lucas oil extender. It's thick and goopy, almost like honey. There are other assembly lubes you can buy, but anything that's meant to stop an engine from smoking, such as Smoke Be Gone or all the other variants, those work well too. Of course you can buy a tube of assembly oil, but I happen to have this sitting on my shelf, so I'm just going to use this. The great thing about an oil this thick is it's not going to run off as I assemble the engine. When reassembling an engine, do not forget to put the woodruff keys in place. There's a keyway at the end of the shaft that makes sure that the generator at the end is turning and not spinning on the shaft. I'm using a hammer to tap it in lightly. I don't want to damage anything here, even though it's not inside the engine. Before putting the crankshaft back in, I'm going to be sure I get a good lubrication on these bearings in here. There's a seal at the top as well. All of this needs to be coated with a good coat of assembly oil, or you could end up damaging the motor which you just rebuilt. So I'm making sure everything is well coated. Then I'll clean off my hands and slide the crankshaft back into place. Of course, it doesn't line up perfectly. The reason why is I never removed the generator on the other side. So I have to turn the generator and line it up with the woodruff key I just installed, and then I can go ahead and put the big nut on it and pull it together. I'm simply using the torque of the nut to draw the crankshaft all the way up. So, holding the flywheel tight, I just crank down on the nut until it seats itself fully. Now it's time to put the pistons and connecting rods in. Again, everything that you reassemble that's going to move needs a good coat of assembly oil. I've got some brand new connecting rods here, but I'm reusing my pistons and rings. As you can see, I've cleaned them up and they cleaned up pretty well. The connecting rod has a number stamped on it to tell you which cylinder it goes in on each side. The cylinders are marked on the other side as I've shown here. All you need to do is be sure that the two machine surfaces rub against each other. There is no bearing between them on this V-twin. Also, note the direction the mark on the piston goes. It goes towards the flywheel. So, making sure that everything is in the proper orientation, I put the wrist pin back through the piston and then reinstall the circlip. Do not forget to reinstall the circlip. Remember that during the assembly process, everything that's going to move needs lubricated. For that, I'm using regular motor oil on the piston rings to get them a good coat. Do not put an engine together with the rings dry. They could seize up and cause the exact problem that this engine had. I'm also going to use some assembly oil in the walls of the cylinder. While this may not entirely be necessary, it makes me feel a little bit better about it. And the worst that's going to happen is it's going to blow a lot of smoke out when I first start the engine up. Once everything is good and coated, I'll go ahead and reinstall the connecting rod and the piston. Again, pay attention to the orientation here if you're going to rebuild it. The problem is the piston won't slide in freely because the rings are in the way. They have to be compressed in order to slide down. They do make a piston ring compressor, but I find that they don't necessarily work very well. You can also just use a hose clamp, but I find the best thing here is just to very carefully use a screwdriver to push the rings in and then work the screwdriver around, twisting the piston slightly sideways as the rings go down in, and then you can just simply pound the piston in place. When pounding the piston in place, it's good to use a soft tool. That's why I'm using the butt of the screwdriver and not a metallic tool. You won't damage it as long as you're not pounding very, very hard. What will damage the engine, however, is scraping with that screwdriver. Be very careful that you're not scoring the head of the engine when you're using that screwdriver. Once the piston drops down in place, all you want to do is line up the con rod with the crankshaft and then go ahead and install your lower bearing. When installing your lower bearings, it's important to note the orientation. There are alignment marks on both the con rod as well as the lower bearing. Be sure they line up. They should go together with a snap. If you don't put them in properly, you can damage the bearings and the con rods inside the engine. Every bolt that goes back in an assembly I feel needs to be lubricated, so I'm just using my assembly oil here. There's actually a different torque for lubricated and non-lubricated bolts, and for some reason very few people follow these. That stated, I couldn't find a torque specification for this assembly. After checking with a few tables, I decided that the proper torque for this was 100 inch-pounds. That seems to be about right, as this is a 6mm bolt, and it should be, considering that it's inside an engine, a grade 8. That seems to be about right and felt good. The next step is to reinstall the valve lifters and the camshaft. Be sure to lubricate the lifters, otherwise they will simply grind on the inside of the engine. There's not a whole lot of oil pressure there, so be careful and get them installed properly. It doesn't seem to matter which side they go on, they all appear to be about the same. Again, lubricate up your camshaft and then go ahead and install it. You'll notice an alignment mark. It's a little dimple on the gear. You want that dimple to line up with the dimple on the gear on the crankshaft. They should line up perfectly. You don't want them to be off even so much as one tooth. If they are, you risk sending the valve right into the piston and damaging the engine permanently. And this will happen instantaneously, as in within the first turn, your engine will be damaged. So be sure those two dimples are lined up when you assemble the engine. I got really lucky here. Usually when you take apart an engine, the gasket paper simply tears and you need a new gasket. And then you need to take a razor blade around the edge and get all the pieces of gasket material off without scoring the engine. Somehow I managed to not only salvage the gasket, but not have to clean it up. I'm using a non-hardening gasket sealer just to be sure it seals, because I'm simply reusing the old gasket. You don't need a thick layer here, don't overdo it. A very thin layer is enough. Again, non-hardening gasket sealer. It seems to be the better option, especially when it comes to oil leaks. In this particular engine, the oil pump is part of the lower case. Other Briggs and Strattons, they have to be installed first before putting the lower case over. Once you install the lower case, be very careful not to fold that oil seal outwards. Push it down, because if you damage that oil seal, it's going to leak, and leak all over the place, requiring the engine to be dismantled again. From here, I'm tapping it in place with a rubber mallet. Again, the reason why is to keep from cracking the case. I've said it many times, I always lubricate a bolt before I put it back in. Not only does it make it easier to pull back out should I need to do so, but lubricated bolt torque is better because it holds the torque between the parts and not on the threads. When tightening these bolts down, I work my way across the case rather than around it. The reason for this is to keep the case from cracking. So I'll typically go corner to corner and tighten them down loosely, and then I'll go ahead and apply the proper torque. Again, I couldn't find a torque specification for this, so I used 140 inch-pounds. These are an 8mm bolt, and that seems to be the proper torque spec. They should be a grade 8, but I don't know. However, 144 inch-pounds is the same as 12 foot-pounds, and that's more than enough to hold this case in place. Because the engine is quite heavy and I don't have an engine lift, I went ahead and reinstalled it in the motor before finishing the assembly. The less weight, the easier it is to put it on the vehicle. My engine used a graphite gasket and left quite a bit of residue on the head. I'm using a razor blade to clean it off, but notice that I'm dragging it backwards. You do not want to put any score marks here, or it'll make it very easy to blow the head gasket. So be very careful when removing this. It doesn't have to be perfect, but you want it to be reasonably smooth. If there's a part that won't come off, lay the blade as flat as possible and push it along that area. Again, be very careful not to score up the metal, or you will end up with either an oil leak or a blown head gasket. The valve springs on this engine are incredibly weak. So weak that I don't even need to grab my valve spring compressor to pull the valves out. The reason I'm pulling the valve out is that I want to replace the oil seal on them. To do that, simply hold the valve in place and then push down on the spring. There will be two keepers that hold it in place. Those keepers can be simply popped out and then the spring can be removed. The valve stem seal is nothing more than a press fit, so just use a pair of pliers to pull it out of there. Just be careful not to score the track that the valve drives in. Go ahead and lubricate the track up real well as the valve stem seal and replace them with a new seal. I highly recommend doing this because an oil burning engine is easy to prevent with just a simple seal. The valve seal is simply pressed back into place. I say simply, but it takes a good bit of force. I don't recommend using any tools here because that valve stem seal can be damaged quite easily. Even though I lubricated the track, it's a good idea to lube up the valve real well before reinstalling it. You'll find that the track is quite tight, so go ahead and push it back inside and it should move reasonably freely. Then go ahead and put your spring back over top of the assembly. Then the lid, and just as you remove the keepers, you put them back in. Push the system down with your fingers and drop the keepers in place. What I'm doing here is setting the keepers on the edge, so when I push the spring down, they should just drop into place by gravity alone. If not, you can go ahead and move them around because it only takes one hand to compress this spring. Now it's time to install the head. I'm using an automotive spark plug anti-seize on the bolts. You don't have to do this, but just in case for some reason I need to take this engine apart again, I want to be sure they come back apart. Anti-seize is designed for very, very high temperatures, so that's the best for when assembling something that's going to get hot like cylinder head. Then just use the bolt to line up the head gasket. As you can see, it's not necessarily intuitive and I got it backwards when I first tried. Everything should line up reasonably close, and the bolts make a great guide to make sure your head gasket is lined up. It doesn't have to be absolutely perfect, but reasonably close. Be very, very careful not to bend up the gasket too much. And then all you want to do is hold the head in place and go ahead and start tightening the bolts by hand. 2 bolts is enough to line everything up straight, and as you can see, this is one of the external bolts because it's all well and rusted. So again, straighten up the cylinder head, line it up, and then go ahead and tighten all the bolts hand tight. When tightening down the head bolts, be sure to use an X pattern moving across the head. I found the appropriate torque for this to be about 15 to 16 foot-pounds. The valve lifters on this engine are different for the intake and the exhaust. The aluminum one is for the intake, the steel one is for the exhaust. Go ahead and look down inside the engine and you'll see the pocket of the lower lifter. Then go ahead and hold the lifting rod in place up against that part, and then go ahead and screw in the rocker arm. For reference, the top of the engine, that is the one I just installed, is the aluminum one. That's the intake. You'll want to repeat this process for the exhaust. Don't worry about setting the valve lash just yet. We'll do that after the rocker arms are good and torqued down. For this assembly, I used a torque of 96 inch-pounds. Again, I couldn't find a torque specification anywhere, but this felt just about right. With everything torqued down, we can go ahead and set the valve lash. You'll want to rotate the engine until you're at the top of the compression stroke. As you can see, my intake valve opens and then begins to close. As it closes, now I'm working my way towards the compression stroke. I'm simply taking a bolt to putting it in the cylinder head and then letting the piston come up and meet it and push it outwards. Be careful when doing this as you don't want to damage the engine. So once it comes all the way up to the top and stops moving or starts going down, now you're at top dead center, or at least close enough to it. From here, you can set your valve lash. Both valves should be loose at this point. The lash spec on this engine is between 4 and 6 thousandths of an inch, so I'm just going to use a 5 thousandths feeler gauge. First, loosen up the nuts on the back side of the rocker arms. Then, go ahead and install your feeler gauge between the rocker arm and the top of the valve. It should slide in and out with a very small amount of friction. That is, it should be tight, but not incredibly tight. Adjust the screw tighter and looser until you get a good amount of friction, but isn't compressing the valve spring. Remember, these valve springs are quite weak, so this can be a little bit of a delicate maneuver here. Technically, you're supposed to use a hex tool to set this. However, I find that just using my thumb to rotate makes sure that I don't over tighten the valve and my lash sets quite easily. Once set, just go ahead and tighten that nut. Now this can change your valve lash a little bit, so it's always a good idea to go back and check. You should, again, be between 4 and 6 thousandths for both valves. Replace the gaskets on the valve covers and then go ahead and reinstall the head covers. You don't want to torque these ones down too much or you can damage it quite easily, so be careful. They should be snug but not tight. Next up is the intake manifold. Again, I greased all the bolts up good when assembling it because, again, lubricated bolt torque is the better way to assemble a machine. Simply line this up and tighten each bolt in place. After this, we'll go ahead and install our carburetor. The carburetor is simply slid over top of the 2 exposed studs. Don't forget to reconnect your governor once it's installed. It's hard to get to it with the airbox in the way. Now you'll want to install your pool starter. One thing you'll notice is that it's very difficult to line it up. There are a lot of screws and parts that have to line up with this. So be careful, line it up straight, and then set everything in place. Be careful that you don't pinch your spark plug wires. The spark plug wires have small cutouts, so just be sure when you're installing this that you don't crush those, otherwise you'll short out your high voltage lead and the engine won't run. Okay, last step is to install the air cleaner and the exhaust system. I leave the exhaust system as the very last component, usually because I just plain forget, and the air intake seems to be, well, right in front of my face. Now, before attempting to start up the mower, make sure you give it at least 20 good solid pulls to get the oil that hopefully you have remembered to install worked around the inside of the engine and coated all the parts. Okay, so motor's rebuilt. I pushed the mower outside in hopefully what is a safe direction. There doesn't seem to be a whole lot this way that I care about it hitting. The radio control system is hooked up, but I have no blade control and I have no throttle control. The blade control isn't a problem, but the throttle means, well, yeah. So with that, well, let's hook it up and see how she goes. Might want to have this handy in case something goes wrong. Well, here goes. Yes! Yes! It lives! Won't turn off! Well, should die any minute now. Turn the fuel off. Whew. Well, guess I should have checked the ignition key to make sure that works. But yeah, so I got a few things to fix. Okay, so it runs. That means the motor rebuild is good. The radio control system does work. But there are a few things I noticed. The very first thing I noticed was that these hydraulic motors don't exactly center like I thought they would. I'd let go of the stick, it'd come back to neutral, but then the vehicle would drift in the same way it was, so I had to give it a little bit of correction the opposite direction. Not sure why that is, But I got to figure that out because that's a pain in the butt. Maybe I'll put a spring damper or something in there, or maybe something in code. Not really sure how to fix that. The other thing I noticed is that this is painfully slow. Just going from here to there, just waiting for the thing to respond, that's too slow. So I'm going to have to bump this pin down a little bit. I gave myself a little bit of room, but it looks like I might have to bend this up to give it more of an angle to clear this here. But that throttle response, when I'm used to an RC car, it's just too daggone slow. So I will have to drill and pin it lower and hope I can get, you know, like that kind of response time, which is still a little bit laggy, but I consider it acceptable. And then, of course, the other things that I noticed when I tried to shut it off is that, well, it didn't shut off. The way I got it to shut off is I turned off the fuel and waited for the carburetor to empty. So, yeah, I don't have throttle control on it yet, of course. I'm just going to hook an RC servo onto the governor down below. I'll just make my own cable, and then I'll hook that up here. But other than that, I'd consider it successful. I mean, I do have the blade engagement connected, but apparently I'm not getting power to the solenoid, which engages the blades. So I'll have to play a little bit with that, because I did expect the blades to spool up when I threw the switch, and it didn't. So a little bit of work to do, but we're getting there. Like I said, the next step after I get this RC stuff all done is FPV. So I'm going to put an HD video system on this once I get it driving right. And that way I can cut my grass from my living room. And then after that, some collision avoidance sensors so I can't run into anything, because I might not be the best at driving this. And then hopefully maybe even try to get it to go autonomous with a pick sock or something like that. You know, I think if I can modify a quadcopter autopilot so it doesn't think it can drift side to side like that and just has to spin and only go forward, I think that would work. The only reason I'm only interested in forward, this obviously goes backwards, albeit slow. The only reason I don't want autopilot to do that is because the collision avoidance sensors will be in the front, and I don't want to back into anything any more than I want to run forward into it. So yeah, a long way to go, but I do now have at least my county's largest and heaviest radio-controlled vehicle. I might be crazy, and as always, keep them flying.